hopefully you guys feel a little better about that quiz, but that's the kind of material you can expect on the test next week. But usually on the test, I usually make some open-ended, some of them are multiple choice to kind of make things a little easier. But I thought that might be a little rougher on some folks because it's been also a while since we really worked one of those problems. So that's why I went ahead and let you guys work together. So I heard some great conversations going on during that, and that's really what I wanted to hear. I heard somebody mention 24.1 inside B, and I remember off the top of my head that one is correct. So it's been a while since I made the key, so I don't remember the others, but I did just glance at it before we started, and I do remember the 24.1 for side B, I want to say. I don't remember. Yeah, so good. All right, well, let me go ahead and just kind of talk to you again. I just want to go ahead and get the characteristics for sine down before we go ahead and take off. Now, remember, sine was going to be this particular cycle over and over and over again. So every time that we go ahead and rotate around the unit circle, let me go ahead and kind of emphasize what it was we had yesterday. If I go one rotation around the unit circle, well, that's one cycle for sine. A second rotation, well, that would be a second cycle. And you can just rotate as many times as you want. And remember, you can also rotate counterclockwise. So that would just result in a cycle the other direction. Okay. So we can just go forever. Let's go ahead and take a look at the critical values. And we're going to be doing this for every one of the graphs. Sine always starts with what? 0. So we start with a 0. Okay. And then we have our first maximum, which is at 1. Then we have a 0. Then we have a minimum. And then we have a 0. We're doing sine. Okay. What? Yeah, we're on sine. Yeah, I'm just drawing it again.
We just went to the range.
Oh, I know. I'm just kind of revisiting the graph. Yeah, I've got this coming up. That was characteristics coming up in just a second. Yeah. Okay. Yeah, we're good. Okay. So here is sine's curve. Remember, the pattern is always the same for every period. Period is the number of radians it takes before you see this repeat itself. This is what we call a cycle. So we always start with a 0. Then we have the maximum. Then we have another 0. Then we have a minimum. And then we have another 0. Okay, so for sine, it's always going to follow that same pattern. Okay. Now, as far as what we did yesterday, I think we got the first two done, right?
Yeah.
Okay, so we said the domain was all reals, so negative to positive infinity. The range, okay, his height, well, the highest he can go is 1, the lowest he can go is -1. So we had these guys right here. Okay, and let's go ahead and get rid of one of the other easy ideas, the y-intercept. Where is this graph crossing the y-axis? Yeah, it's just a 0, 0, right? Okay. Now I'll come back and draw some more of that graph after I write down the 0, 0. So let's see here. I'm going to see this cycle, this pattern, just over and over again. So this represents one revolution. And then I would go, there's a second revolution, and there's the start of a third. And I can also rotate clockwise, as I was just saying. So it would go down here, probably look something like this. Okay. Now, all the distances, everything you see is always going to be the same. Okay. You'll notice it goes from 0 to 2 pi, and then that same cycle repeats again. So this guy right here would be 4 pi, right? Okay. Every cycle, every period is going to be 2 pi for sine. Well, let's take a look at the x-intercepts, the maximums, and the minimums. Because this graph is just going to be able to go forever, how many of these am I going to have? We're going to have an infinite number of each of these three. The x-intercepts, the maximums, and the minimums. So I'm going to help you work through these together. Because there's an infinite number, we can't just list every single one of them. There's no possible way we could do that. So we want to do the next best thing. We want to come up with an expression that would find each of these locations for me. Let's start with the x-intercepts. Okay. So this one right here, this is my first one. See, here's my second one. Every time it touches the x-axis, that's an x-intercept, right? So I would go here, and I can even continue it on the parts of the graph that are off the grid. Okay, well, here's my question. How far is it from one intercept to the other? It's always pi units, right? Okay. Now, let's think about this. If I start at 0 and I add pi, I'm at an intercept. But then to get to the next intercept, plus pi, plus pi, plus pi. I'm just going to keep doing that over and over again, right? So it just looks like I'm adding what? Is it just pi? Now think about it. Let me go ahead and maybe do this one. Okay. Like here's the first one, so this is plus pi, right? So to get to this one, I would have to add 2 pi's. To get to this one, I would have to add 3 pi. So it looks like I'm adding multiples of pi. Okay. So that's where I'm going to find my x-intercepts. But see, we just need some variable to represent, our multiples. So let's just say k. Okay? Okay, yeah. So let's say, wrong one, intercepts. So let's just say pi k. But we want to go ahead and say that k is an integer. Okay, now you may or may not recall the integers, those were made of, let me go ahead and write these down here. This had 0, your positive counting numbers, and it also had what? They're negatives, they're opposites. So we had -1, -2, ... So see, these are the values of k that I'm saying we can multiply by. Like pi times 0 would give me the 0. Pi times 1, pi times 2, pi times 3. And to go in the other direction, pi times -1, that would just push me left. Is everybody okay with that? Okay. All right. Well, let's do the same thing for the maximums. All right. But let's start with the very first maximum I have. Where does it occur? Oh, now it happens at 1, but it starts at pi over 2, right? Okay, so here's my question. Here's my first maximum. Now, how long is it going to be until I get to the maximum again? Remember, it's 2 pi units, right? Okay, so do the same thing that we did just a moment ago for the x-intercepts. Like if I'm starting here at pi over 2, it's going to take 1 2 pi radian to get to the next major, okay, or maximum. Well, how many more to get to the next one? Another 2 pi, well, that's 2 total, right? So here it looks like I'm just adding multiples of 2 pi. So I'm going to say pi over 2 plus 2 pi k. Again, we're going to say that k is what? Is an integer. Pi over 2 plus 2 pi times 1 plus 2 pi times 2 plus 2 pi times 3. Is everybody okay with this? This specifically, no, but the characteristics will be, like sketching, stuff like that. Okay. All right. Now, help me out with the minimum then. Okay. Now, I'm not going to go ahead and give it to you. I want you to try this one on your own. Here's the first minimum. Let me go ahead and choose this one right here. So where does it occur? 3 pi over 2. Well, how long will it take to get to the next minimum? 2 pi. Well, from here, how long would it take to get to the next minimum? 2 pi. To the next one, 2 pi. So do exactly what we did just a moment ago. Write down what you think the expression is going to be for every minimum we have on the graph. But we're going to go ahead and start it at 3 pi over 2. Okay, so can anybody tell me, what should I put? There you go. 3 pi over 2 plus 2 pi k. I'm just adding or subtracting multiples of 2 pi to keep getting every minimum as I go. We just want to go ahead and make sure to say k belongs to the integers. Okay. Is it continuous? And remember, the basic definition of continuity, I can draw it with my pencil without doing what? Without picking it up. So yeah, I can sit here, there's 1, there's 2, there's 3, and I can just keep going for as long as I want. So it's definitely continuous. Is it bounded above? That means does it go to positive infinity? No, so it is bounded, right? What's the highest it can go? 1. So it is bounded above. Is it bounded below? Yes, the lowest it can go is -1. All right, and I'll tell you what, we got 1234. So I say we got to a pretty good spot. Let's go ahead and stop there. Okay.